Hello, I'm Kevin Jones and I live in Calgary, Alberta, and I have a confession to make. I'm an audiophile. I wanted to do a short follow-up video to building a high-end audio system with a look at what you're really paying for in a high-end audio component. Certainly the final experience is in the listening, but I'd like to provide a brief overview to address in very simple terms why these factors can have an impact on performance. So here's what I'll be looking at. First of all, some marketing basics and component costs in terms of the enclosure, power supply, circuits, and speakers, and discuss how these impact performance. I'm not going to get into a long dissertation on marketing theory, but let's look at some common costs in any product. After all, if a business can't make a profit, they won't be in business. Built into the retail price of any product are things like development or R&D costs, marketing, distribution, and packaging costs. Most high-end companies are smaller than the big general consumer businesses, and I'll use companies like with names like Sony and Panasonic as example household names in consumer electronics. The reason is simple. High-end audio is a very niche market, and most people want the cheapest, best-looking audio product they can get for their money, and sound performance is really no more than an afterthought. For those few audiophiles, regardless of their financial means, they want the best performance for their dollars. This is a difference in value perception. So let's start looking at some specifics here. And remember, this is an overview. Each one of these topics that follow could be discussed for hours on end, and I'm just not going to get into that. Visually, there are some pretty good-looking products in the marketplace, regardless of the price point. However, on closer examination, you'll generally find a difference in the quality of the enclosures, both individual components and speakers, and I'll address speakers separately a little later. It's easy to see that a thin sheet metal and or plastic enclosure is going to cost less than a rigidly constructed one. As an example, Linn, one high-end audio company, actually machines the enclosures for their most expensive components from a single block of aluminum. And you can imagine that this is both costly and time-consuming. Yes, they are trying to be visually appealing, but the technical reason they do this is to control vibrations. And yes, electronic circuits are subject to vibrations which affect the sound performance. If you lift a mass market component up, you'll find that it probably weighs much less than a high-end one. And there's a very simple reason for this. The power supply, and more specifically the transformers. Power supplies are critical to performance. For those of you that didn't realize this, electronic circuits run on DC. Motors in things like washing machines, dishwashers, and electric fans run off the 120 volt AC power lines. AC power delivered to your home works, but to use an expression, it's dirty. Those same motors create a lot of back EMF in terms of various frequencies that are retransmitted back through those same power lines and from all your neighbors as well. Building a high-quality, reliable power supply is expensive, and in some cases like Linn, which uses a switch-mode power supply, are tricky to design as well. A quality power supply provides clean power for the circuits in a very responsive way. Music, as you know, can go from very quiet to very loud very quickly. If the power supply can't provide the power needed to deliver those dynamics, performance, and I'm talking sound quality here, will suffer. So let's move on to circuit design and parts quality. Yes, there are big differences here as well. An inexpensive design using lots of feedback affects the sound quality. An amplifier does require feedback, basically to keep it under control and keep it from blowing up in very simple terms. But feedback is basically distortion. A high-end product will design with judicious use of feedback. Op-amps are very simple, cheap amplifiers used in many internal circuit applications very effectively. Where sound quality is concerned, however, Discrete circuits, and by this I mean circuits using individual components like resistors and transistors, they will have a much higher sound quality. As an example, even in some high-end components that have both fixed and variable outputs, such as a CD player, it may be convenient to be able to control the volume with these, but these variable volume controls using op-amps invariably degrade the sound. As a suggestion, always use the fixed outputs on components. Why is there a difference in sound quality from one CD player or D to A converter? Digital playback has many problems to solve over and above the analog sound reproduction. Yes, there are very cheap D to A chips available, but they don't do a very good job converting those digital signals to analog, which is what you actually listen to. Quality D to A converters are much more expensive, and the sound quality you get is just quite obvious. The message here is that there are various levels of parts quality available to design with corresponding results for either a mass market component or a high-end one. Same goes for speakers as well. A rigidly constructed box that controls vibration is more costly than an inexpensive one that doesn't. The vibrations and resonances from that cheap box just don't disappear. They come back to haunt you. They are re-radiated from that same box later and are basically distortion and or an unnatural frequency exaggeration. Again, something you will hear. Try tapping on different speakers with your knuckle. Does it sound like a solid block of wood, or do you hear a long boom? I hope you've found this brief discussion of use in your search for a better musical listening experience. So thanks very much for listening.